Hello, welcome to the Data Channel, and you're watching Python Bootcamp for Data Professionals. And as part of this topic 24, in this series, we'll be discussing again one of the important topic, but very least discussed. But we think it is important to understand if you are especially a developer, right? And if you want to understand the internals of the Python code that you are writing, so this video is kind of important to help you understand the internals of the bytecode. That means how do you disassemble the Python bytecode so that you can understand what exactly going in behind the scenes. Because so whenever, as you know, right, from the previous videos, like Python converts like the code into a bytecode because it has to be a machine readable format, then only machine can execute it. But how exactly it is actually treating that, or how exactly it is getting the conversion to the bytecode. So if developer can understand that, so that he can code it in a better way, because whatever the code he writes as a developer might be sometimes misconvinced or misconverted into a bytecode. What we say is like it might not be exactly how developer is expecting. So if he understand by disassembling the code, it will be easy for developer to kind of improvise that code and rewrite the code and tweak the code. So before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So quickly we'll see what is that you are going to see in this particular video. So definitely, what is the purpose of benefits of disassembling the Python bytecode and read, and also we'll see what are the different use cases for developers, because this video is especially for developers who want to understand that in detail. So that's important, and we will understand what is a basic usage or basic syntax that you can basic code, right, to use that, and also how to use this dis model. So this is a disassemble model in Python, so how to use that. Okay. And also we'll see how to interpret the output, because once the disassemble code, you will disassemble the code Python bytecode, it will give certain statistics. So how to read that statistics to understand, so that we will see. And also we will see certain practical examples of how exactly the Python will disassemble the code using a certain syntax or usage that we'll be seeing, right? And so now if you see the benefits of understanding the bytecode is definitely, so we can identify inefficiencies. So identify inefficiencies means like you can spot unnecessary operations or suboptimal code paths which is not as expected by you, so as a developer, right? And also you can have like optimized performance. So that means you can rewrite the parts of the code so that are performance that are having some performance bottlenecks. So you can identify them, and you can rewrite the code and tweak the code accordingly to make it more optimized code when it is getting from the perspective of bytecode conversion, right? And you can also understand the Python internals. That means you can gain a kind of insight into how Python executing code, which is beneficial for advanced debugging and optimization tasks. Because especially if you want to, if you're working in a real-time projects where performance is very important, and you should be very careful as a developer to kind of understand all these internals, so that you have that complete control of the code, what is going behind the scenes, and it will be very easy for you to debug and optimize the particular code. Okay. So with that, what are the use case for developers? So definitely you might be thinking, okay, we know the benefits, but how exactly it will be useful for the developers, right? First is debugging, because as a developer you need to understand the code at a very low level. Okay, so you can write the program, maybe it is having a multiple for each loop, multiple methods, you are using different data types, data structures, right? And the control flow of the program, so it might be like a 2000 or 3000 line of code, and it will be very crucial to understand how exactly the code is moving. So what is the path of the code? So is it taking the right path as expected in a certain scenarios? Okay, if you are using a certain parameters, so when you pass certain xyz parameter, is it behaving in a way you want? Okay, so that is kind of important to diagnose like why certain code paths are being executed and why certain paths are not executed, and you can evaluate that when you are debugging the code. And optimization, as we already discussed, identifying inefficient code, uh, definitely the bytecode will be helpful, and also comparing the bytecode of different implementation to choose the most efficient one. So this is quite important and interesting, right? Suppose you want to implement certain use case or solution, okay, and you will write a developer one can write a way of like way of implementing that, and developer 2 can write the same solution in a different way, because each developer think in a different way. He might use list, another developer can use tuple, and he might use for loop, and another can use while loop, okay, and another developer can use for loop something, right? So it depends on how exactly they think. So every developers will be different, and each developer also can think of writing a different code in different ways, one code in different ways, right? And you can really compare that uh, compare the different codes which will give the same solution by using this disassembling of the bytecode method. And once you do that, it will be very useful to choose which is better one, okay, and it is very easy to compare, okay. And also it will be helpful for learning and teaching. So Python, like as you see, like there are a lot of scope for learning, and you are also, it is learning is always, it's a continuous improvement process, right? So you might be working on list, you might be working on dictionary, you might be working on certain loop conditions. So you want to continuously learn what is going inside the code, and you might be teaching or mentoring others. Even in that cases, you might be collaborating with different team members. Even in that cases, it will be helpful. This method will be helpful. And also inspecting the compiled code. So as you like, it's like verify what the Python interpreter is executing, useful for security auditing and code validation. Okay, so in certain cases it can be used in that cases as well, to see the compliance or security or auditing purpose, and performing a code validation whether it is going as per the expectation. Okay, so with that, now we will quickly jump to the practicals of it. So firstly we will understand so the dis module. So what is dis module, right? So dis module is a internal library of Python. Okay, so like any other library, so this is also a library here, okay, in Python, and we can use this for disassembling the code. Okay, so this is a module or a library in inbuilt library, right? And it's used to disassemble the Python bytecode in more human readable form, because the bytecode actually, if you see, it is not a human readable format, but if you want to make it human readable, so then you go for this module. Okay, and this can incredibly useful for developers for several reasons that we already saw, right? And this function, how it disassembles the Python code and methods and different code objects, so that we will see. Okay, but before that we will see the basic usage, how exactly to use a disassemble module. Okay, so definitely first is you need to import. Okay, import this module. Try to execute this. As you saw, it is executed. That means it's imported the dis module. And then you can have disassemble a code. Like first we will see how to disassemble the function. Suppose you have written a function here, a comma b. It is taking two parameters, and you are trying to return the value which is a plus b. Okay. So and you want to disassemble the code and see what exactly this particular function looks like. Okay, so what you are doing, so this is a method, and then you are dis, and you are passing the function itself here. So this is how you disassemble the function and see what exactly is internally. So this is what the dis module output looks like. So this is a bytecode, but it is the same bytecode which machine execute internally, but it is more readable when you are using dis.dis function. And you can see here different parameters. It is giving the disassembling the function, pass a function object, and what we did is disassembling a code object, okay, using compile to create a dis.dis here. And finally we have directly passed the dis.dis, using this dis.dis we have already passed the exact function name itself. So this is just an example, right? And you can disassemble um, the code object as well. Suppose you have something like this, where you can see you have a code object. That means you want to compile a particular line. So you can pass even a program here, or you can pass the number of statements that you want to executing with the comma separated values, and then if you do disassemble, so it will give you the output something similar to this. Okay. And so now we know actually what exactly, how exactly it is giving the this thing, right? But how to read this? So that is important, right? So we got the output, but how to read it? Okay, how to interpret that output? Okay, so dis.dis, whatever output it gives, right? It is having first is the line number. It has a line number. It has a offset. Okay, and it has a opcode name, the name of the bytecode operation. It has the argument. It has the argument details in the human readable format. So for this to understand in detail, we will take a better example. Okay, one practical examples we will take, right? So this is my function. So it is actually having a, we are passing a x variable, x parameter, and this x parameter, if it is greater than 10, we are returning something. If it is else, we are returning something else. Okay, and the same function, what it is doing, I want to know. So how would, what is the bytecode version of this particular function I want to know, right? So that's why I'm using dis.dis, and then I'm passing the function name itself. So now, so it is giving this particular result, and here in this particular result, the load fast. So this particular one is, it's a load a local variable. So how much local variable are loaded now? So it is 0 local variables, right? So that is why it doesn't have any local variable. Suppose if I have a local variable here, like say c equal to some Python, some list, some variable I want to define, right? So now you can see, so it is giving build fast and store fast. It is giving 1c here. Okay, and load fast, it is still uh, it's having 0x, but it is giving store fast as one variable here, and which is c. Okay, if I don't give this, so it will not give this variable itself, right? So it is just giving a load fast and a load constant. So the definition of load fast is load a local variable, and the definition of load constant, load a constant value. So here there is a constant value, right? So there is a constant value 10. Okay, and then again there is a constant value 2, if you see here, right? So this is a constant values, 2 and 2, these are the constant values. So this is first category, and this is for if condition, then this is for else condition. So in the if condition, as you can see, load fast is having 0, and then load constant is 2. Okay, and then there is a return value which is it doesn't have, because it is returning, it doesn't have anything to kind of store it as a bytecode. And bit operation is here, it is star. Okay, and in another case bit operation is plus. So as you can see, it is bit operation is plus here. And it's so here like pop jump if false. So what this means is it specifies jump to a specified bytecode offset if the top of the stack is false. So it's like a, you can understand a pop jump if else here in this case. And binary multiply, so there is something called as binary multiply. Okay, and there is a, so these are binary operations, right? It's like, is it might be a multiplication. This is binary multiplication, and in one other case we are doing a binary addition. And we have a return value, so which will specify return of a value from a function. So in this case I'm not calling any functions, right? So that's why it's not returning anything here. Okay, based on the return whatever I'm passing, so it should return. So like if I pass, say for example, if I'm uh, calling this function and it is actually returning any value, so then it will display the return value here. Okay, so that's how you read it as a developer, right? And there might be a number of examples. As I said, if you can define a constant value here, and you see how the code change. Okay, now it is added this one store fast as 1c, right? This c has been added here. So these are all variables, x, c. Okay, so So these are all variables and it return types. So all this will be, and as the code is complicated, it becomes complicated, right? You can see uh, lot of things getting added here, but these are the few basic things. But if you start using it extensively, so then you can start understanding each and every definitions of it. Okay. So as we previously mentioned, right? So we can compare two different codes. So suppose you want to like write a same solution in two different formats. You can compare that how exactly it is getting internally executed, right? So the first example we will take a traditional for loop, right? So you can write a traditional for loop, okay, using this method. So using a particular, so I'm just doing a for loop here, right? So in this function, what I'm doing is I'm just executing the for each loop. Okay, and so we will try to execute and see how exactly the bytecode looks like. Okay, so this is how the bytecode looks like, right? We have a build list, store list, which is 0, load global, what are the number of global parameters or functions. So there is null plus range, load constant, there is one constant here, which is 10. This is a 10. Okay, and how many calls are there? There's one call. Okay, and how many iterations are there? Okay, how many store fasts are there? This is the iteration value. I'm iterating I here. Okay, so there are many different internal details you can, so we cannot practically go and explain each and everything, but as and when you want to debug a particular line of code, it will be helpful. So now the same thing we will try to compare with the list comprehension. Okay, the same code we are writing using list comprehension. So the same code, okay, instead of writing it this way, I am writing in this way, which is a list comprehension, and then I'll try to execute this and see, right? See, it is having a its own result here. Okay, and it is giving a exception table and all these values. So just by looking into this, okay, so here you can see the number of instructions, right? So it is like 4, 5, 6, 7, and then 6, 8. So you can see the number of instructions it is generating. It's 1, 2, 3, 4, 5, 6 instructions, kind of instructions, right? But here you see the number of instructions. It is just two instructions. Even though within the instructions there are variables are there, but instructions, the number of instructions has reduced. That means you can say that list comprehension is more performance intensive, or it is better for performance when it is compared to the traditional way of writing in a for loop, right? And as we had discussed in the previous video, list comprehension is faster, and you can go and see that detailed video why list comprehension is faster. And this is one of the example or proof why the list comprehension is faster than the traditional for loop. So we have seen that using the by disassembling the code. Okay. So hope this concept of disassembling of the bytecode was useful, and thanks for watching.